Information Technology. Assalamu alaikum. Very good morning. Namaskar. I, Tunga Arundhati, Assistant Professor, Department of Computer Science and Information Technology, welcome each one of you to the second day of 8th International Conference on Research in Computing in Engineering, organizing by Department of Computer Science and Information Technology, Manu, and Universidad Don Bosco, El Salvador, Central America. Now may I request our keynote speaker, Dr. Atul Negi sir, Professor in School of Computer and Information Sciences, University of Hyderabad. Please come on to the dais stage with a round big applause. Now I may request Ms. Khalida Afroz to honor with a bunch of flowers to Dr. Atul Negi sir. Give a big applause. Thank you, Ms. Khalida Afroz. Now I may request Professor Pradeep Kumar, Convener, Rice, Head, Department of Computer Science and Information Technology. Please come on to the stage and occupy your place. Now I request Ms. Afra Fatima to honor with a bunch of flowers to Dr. Pradeep Kumar sir. Thank you, Afra.
It is for you all, to the participants and the present here, one and all. Thank you so very much.
It's my honor to read a little profile Atul Negi sir. He is a professor in School of Computer and Information Sciences, University of Hyderabad. Sir, area of interest is pattern recognition and its applications, Indian language, OCR, computer networks. Sir has given 20 journals, and sir has 731 citations, and he has published many papers in 96 conference proceedings and one book chapter also. Ladies and gentlemen, everything is defined and realized with the software and data, which have become the soul and blood of the world. Computing power is the engine of the world. Intelligent systems are ubiquitous and intelligent computing is booming. However, the kernel of the intelligent systems is mathematics. So, distinguished participants and dear students, to get a good grip in mathematics and statistics, to do research, to build the intelligent systems. Now I request to give a keynote speak on research in computing in engineering. I request Atul Negi sir to occupy the stage and deliver the importance in research in computing and intelligence. Thank you, sir.
This is not open in browser, is it?
Yes, this place has.
Don't we have microbat? Okay, open the. Yes. Okay, nice. You can use this one. Sure, sure. Okay. Good morning to everyone here, and whoever is online, their appropriate time, I'm not too sure about that. So, okay, thank you so much. So, this talk of mine is about an already published work which has appeared in IEEE Explore. So, and that this published work also is based upon entirely my own research work. Okay, all my research work with my students. This work is based upon that over the years of time, and I think this is appropriate for this conference where we are looking at the intelligent computing, right? So intelligent computing in engineering is the theme for this conference. So, and I am talking about the computing systems itself, right? So, as you can see, I am from University of Hyderabad. University of Hyderabad is a central university like here. It is just a few kilometers away towards the western side on the same main road which is there. Okay, and this is the article based upon which my this talk is based. You can, if you are able to have the IEEE Explore access, you can download the article, or else if you are not able to download the article, please let me know. I will share the article with the organizers here, and they can give it to you, so that way you will be able to get the article. So basically, I have some introduction about AI, the applications, different types of applications which are there in engineering. In engineering, we always look at the data processing aspects, signal processing aspects, and things like that. The human-computer interaction is also very important. The computing systems to neural networks and things like that. So these are some of the applications. If I go through the entire article, there are more than 40 references of mine which are there in this. So it will be too long to cover all of them. Here I'm just giving some kind of a snapshot of what is being done. So So the idea is that advancements in machine learning and AI are leading to better systems. Now we are talking about systems as such. So, and why do we want to use machine learning and AI in the systems? Because we would like them to capture whatever is latent information, and then that can be used for a better operation. Okay, so we have techniques which are like, say, deep learning. All right, deep learning is good. It is performing very well. However, there is one very big problem with deep learning. As some of you are aware, it needs very vast amounts of data, very large amounts of data. Okay, so you always have this problem with deep learning that there is insufficient data, and by which, of course, there is some research which is going on by which they want to mitigate this problem of deep learning. But until then, actually, what has happened is that previously we had very good AI systems which did not require that much amount of data. Of course, for any machine learning system, you need data. It is it's absolutely needed. However, the conventional machine learning approaches, which I am describing in this work, they are quite adequate for many of these purposes. Okay, so that's why I am calling it as a traditional ML or AI approach. Okay. Now in artificial intelligence, I'm not too sure what this audience has an exposure to AI as such. There are too many kind of misconceptions with respect to AI. Here I'm trying to just make it clear what we are talking about. Okay, so as I'm showing this that an artificial intelligence system is going to be performing like a human being and all that, but any AI system is involving reasoning, all right, and the system makes a independent choice. Basically, in a environment, the system is interacting and it is able to make an independent choice. So basically, that is what is the crucial thing with respect to an AI system. Okay, and this AI system cannot just stand in the air unless it is supported by the information technology methods. As I am showing here, that is the technology which is related to storage, retrieval, transmission, manipulation of information. Unless you have that information technology base, these things will not work. And as we are talking about computer science, so with what is it which makes AI kind of applications a bit different? So here there are two axes by which we are looking at computation. One axis is the type of information which is being processed. Another axis is that what is the method or approach which is used. Okay. Now on the top left quadrant we are having conventional computing, meaning that suppose number crunching kind of things. The inputs are all numeric and the algorithms are well known, and you are able to do the number crunching, which is your scientific computation. Okay. However, like let's say if we talk about databases, in databases we don't really have too much of numeric computation. In databases we are having, or we talk about the information databases, symbolic computation. Alright, so that is the top right quadrant, which is that it is algorithmic but symbolic. However, when we talk about AI, the AI is in the bottom right quadrant, where it is the methods are heuristic methods and the type of information is symbolic. Alright, so where these two things are there, that is what is going to make for an AI kind of an approach. Alright, so I hope this is clear with everyone. In AI we have categories like strong AI and weak AI. Strong AI is that where we are using let's say the solutions for playing chess. So in strong AI the system is very strong. Even a human being cannot at all beat. In fact, now earlier the grandmasters were defeating some AI systems, but now the computation has gone so much forward that you cannot easily beat even a grandmaster cannot beat an AI system in chess. However, there are so many other simple tasks, everyday tasks, which the computer systems are not at all able to do or do it properly. Okay, those are the weak AI kind of things. okay, which human beings in everyday matters are much better. Now, to judge an AI system, whether an AI system, how is it performance, we have that Turing test. This is a well-known test. Okay, whenever we talk about AI systems, Turing test is the most historically important one. Okay. However, I would like to tell you that now Turing test is sort of bypassed, or rather it is obsolete. Okay, because the performance of many systems is, just for example, I am sure everyone in this room is aware of Chat GPT, correct? So, in fact, let me look at the other way around. If somebody is not aware of Chat GPT, can I know if there is somebody with that kind of a thing? Okay, it doesn't look like it, right? So, everyone is aware of things like Chat GPT. Now, Chat GPT is exactly the kind of thing which the Turing test was supposed to have been testing. Alright? So, it is very difficult now that the Turing test is there, but there are other kinds of things. I am not going to go into what is a Turing test and how it is being challenged. Now we are having so many kind of things where the things are obsolete, right? So I won't go into that. And but okay, from a perspective of being able to say that how AI systems are useful, this is what we are looking at. That we are looking at that in AI we used to have rule-based systems. Okay, I am from the era where I have studied artificial intelligence. I am a student of artificial intelligence since 1986 onwards. Okay, so when I studied the first time I studied the AI course was in 1986 at the Indian Institute of Science in Bangalore. My professor had just come from the United States and he was talking about expert systems. That is called the rule-based systems. Okay, these used to work based on the prediction where they had the predefined rules, and the expert was there to sort of pull down the rules and put it into the system. And it would work only on some very structured data sets itself. But it could not detect any hidden patterns in the data. So now, to improve upon that, came up the machine learning systems. In the machine learning systems, as you are well aware, that we try to get the statistical models, and we try to use probability methods to uncover the data which is behind the model, and then through this we will be able to uncover and find out some hidden patterns inside the data. Okay. In fact, another buzzword which is going around these days, that is data science and things like that. So this is really the core of things where it is also called as data science and things like that. So anyway, now what was the next step further? The next step further was that we could suppose we have unstructured data. So in the unstructured data, that is text, speech, imagery, and that is where the deep learning approaches came in. And then in deep learning onwards, we had data centers, and there was a huge capturing of the text data, speech data, imagery, and all that. And through that, using the deep networks, the contents were started to be analyzed. Okay, so this is the progression of the field in AI. And this slide shows that how the interrelationships are between the rule-based reasoning, deep learning, machine learning, and all such kind of things. So you can say that data science is something which is a huge thing which is there to the side, where everything is being plugged into the data science. Everything will work only if there is proper data science. Okay. This is basically your a quick overview of how does machine learning work? Because in machine learning we start with the historical data, then we have we use the training and make predictive algorithms, and that will give you the model. Okay, the model is there on the top right. However, when you test the model, you are going to get in the second stage you get the new data, and then with that you will apply to the model. When you apply to the model, then it is going to show the predictions. Okay, so this is how we actually work with the machine learning. And machine learning has come a long way. Okay, and as the systems were going to do well, then the machine learning systems got more and more into play. However, what happened with machine learning was that the performance would sort of sort of saturate to some extent. Okay, what is the solution? The solution is that in deep learning, in deep learning, as you can see, the training was directly from the data instead of the feature which we were doing. That is, we were doing the feature engineering, okay, manual feature engineering. So that's how deep learning was doing better. Now, as to come to machine learning and in their applications in the engineering systems, I have made some categorization, and this is based upon my view of the things, or rather the fields where I have worked. Okay, so one aspect is called as the signals and data processing. Okay, and then in this I have contributions in the principal component analysis methods, which is one of the well-known statistical methods, and in the sparse representations. And then I worked on the human-computer interaction systems, where it is about OCR, and there we have worked on the OCR for the in the Telugu script. Okay, so that's what was the work from the University of Hyderabad, and this was a long-running project and ran for about 15-16 years. Then another thing is about the computer systems. How do we apply machine learning in the computer systems? And then, how do I characterize a system's performance? And how do I look at the system security? This is another application where the machine learning was important. And then finally, some applications of neural networks. This is just a kind of a survey of what we are doing. In signal data processing, what happens is that sparse representations are very important. Sparse representation means that although there is a data, it's a signal data, the data is very vast, but we don't always deal with raw data. We try to deal with the data which is somewhat more in a comprehensible or digestible format. Okay, for that, one of the important things to do is that you reduce the dimensionality. Okay, so that is the dimensionality reduction methods are very important for that. PCA is one of the well-known and important methods for dimensionality reduction. In the first method which I am talking about, which my students are working on now, that is called as the sparse representations. So here what we do is that this is a slightly different aspect as compared to the principal components, where the feature dimensions are orthogonal. Okay. However, there may be some feature dimensions. Rather, there may be a region in space where there is a distribution of the dimension of the data, but applying orthogonality there will not lead to a proper compression of the information. So that's where we look for dictionary learning approaches, where we build a code book. Okay. The orthogonal transforms, which is there well known in signal processing, like Fourier transform, discrete coefficient transform, these things are orthogonal methods, but the dictionaries which are learned from this are not so expressive. Okay, it takes a huge lot of coefficients from these to be able to reconstruct your original data. Instead, we are having some kind of a machine learning approach which is applied to the data dictionaries. So here what we do is they make a optimization function and we try to solve that. Okay, suppose X is your data and then I have a D as a dictionary, and what I am trying to do is that I am trying to have the sparse representation, which I call as D dash here, okay, with a sparsity constraint, that is this alpha, under which within the sparsity limit we will be able to solve this, and we try to minimize this optimization function. Okay, this gives us the dictionary which is going to give us a very compact representation of the data. And in the previously published work, we have given some methods by which this can be done, and a heuristic approach for this solving this has been presented in this thing. Okay. There is also a lot of work on PCA where I have that is, it's a tool for the dimensional reduction, and in PCA we try to find out the k eigenvectors by which the projections are taken, entire projections of data are taken onto that dimensions, and that is trying to capture most of that information in the data, and but however trying to reduce the dimensions which are there. And so in my research work, when the dimensionality becomes very, very large, I have proposed an approach which is called as sub-X PCA. In sub-X PCA, we find the subspaces, and by using feature partitioning approach. And we have proved, and there are theoretical as well as the computational proofs, that sub-X PCA is in fact the concept of sub-X PCA includes PCA as a subset. Alright, so the sub-X PCA is a generalization of the PCA. Alright, and the important thing is that sub-X PCA is able to capture global as well as local variations in the sub-patterns. Next work is on the human-computer interaction. Okay, so when we are interacting with computing systems, we are either interacting with whatever our human senses are. Mostly our senses like vision. Okay, we are using our eyes, or we are using say like speech or talking. But traditionally, what happened was that we had the typewriters and the teletypes, and then from then the next big contribution for human-computer interaction was the visual one, which is through mouse. Okay, but the ones where the previous processing power could not match up was that to be able to interact with speech. So nowadays that is the one which is coming up. It is still far from perfect, and for those who are blind, you have the assistive technologies where the speech interfaces are coming into being. Okay, but on the other hand, that without typing, can I input data into the computer? Okay, this is what everyone would like to do a lot. Okay, so like let's say if I have a book which is there in a printed form, how do I get that information from that printed form book into the computer? Okay, so that is possible through the mechanism which is called as optical character recognition. Okay, so OCR is something which is not at all new. It has a history of more than 100 years. Okay, but in the recent years, that OCR has really become perfected thanks to the deep learning and the recognition methods. What I am talking about is that it is a kind of a printed OCR work which is unique for index scripts. Okay, this was all done under the Ministry of Information Technology projects, for which at the University of Hyderabad we are a part from since year 2000 to 2016 when the project closed. So we are part of that, and this work is being done. I have worked on several index scripts, that is, I worked on the Telugu, Gujarati and Kannada scripts. Okay, there are others who have done much better, but these are only my methods which are there. So, as we are in Hyderabad, Telugu is the very important script, and it has more than 100 million speakers in the Telugu language. So in say neighboring states of Andhra Pradesh, some border areas of Tamil Nadu, Karnataka, even Orissa, and all these places, Telugu is a very important language. But when we come to the documents, so it is a script. There is a different script, and this Telugu script is not so easy for learning, or So, but it is part of all our index scripts where it is phonetic. Alright. And when it is printed, we have touching characters problem and binarization problems. So these are the problems which were looked at, and I'll just maybe go through very quickly that the stages where we do what. So we start first with binarization. We take the images and we make it into 0 and 1 black and white images. Okay, and then there what happens is that there is a bit of distortion which is introduced by the binarization process. Okay, which makes our recognition a bit difficult. So we came through with some methods where this was sort of bypassed, and we came up with methods which will segment, which will break up an image and it will turn it into words, sentences, and the individual characters. Okay, so these were the methods which we were there. Each individual character or component, it is called as component. So we did recognition based on components. And this is the actually the basis of the work which we the method which we used. Okay, that is called as fringe distance. So in the fringe distance, what happens is that we take a binary image and then we do what is called as a distance transformation. And we see that, suppose you take the black part of the image and we say that we compute the distance from the black part of the image to, or rather from the white part to any black part. Okay, so every black part is going to get a 0 in the image, and the others will, the background will get a number which is based on the distance to the black part. Okay, if any of you know Telugu script, can easily recognize from the image which you can see. Which letter is that? Correct. So this is the okay. In the there are two R's, right? Small R or big R. Which one is it?
Small.
Right. So this is the small. Okay. For you visually it is very easy to identify. Okay, because where we have put the numbers into that, that numbers are very easy for you to identify. Now, how can we make it very simple even for the computing systems? Okay, so the feature transformation which we did is doing exactly that. Now what we do is that if you want to compare this with any other input character, you will simply compute the same fringe distance for that input character, and then we will put this on top of that other character, and we will simply count that what is the total number which is coming up. Okay, so what will happen is that wherever it is 0, that number will be 0. Okay, the sum will be 0, and then otherwise we will just sum up that the numbers which is there on a pixel to pixel matching. So what will happen is that if there is more matching in the black region, the score will be less. If there is more of the other scores, that score will be high. So this is the basis for us to make a distance. So if the character is matching very well, then the distance will be less, and if it is not matching, the distance will be high. Okay, this is just the basic concept by which the fringe distance is allowing us to match the characters. Okay, this is the core of our approach. Okay, although as simple as it looks like, this was very successful. Okay, and we used this same computation approach also to segment the data, and this is how we could segment the data. That is, we take a line and then we are able to find out the different parts of it. Segmentation just means finding parts of it. The kinds of parts we want: lines, we want words, and we want the individual characters. Okay, so like this, we could do that. But of course, our method is not so perfect. Some problems were there, and then we tried hidden Markov models for recognition and things like that. And this is kind of view. Similarly, approaches were there for Kannada and Gujarati also. Okay, and then more difficult problems. More difficult problems is this related to handwriting character recognition. Okay, so again, this is here where the training data set is very important. Okay, so still work is going on in this. We are still trying to collect. We are trying to collect a huge amount of the handwritten data. Why is handwritten data more difficult? Because there is so much more variability. Almost every individual writes in their own peculiar different way. Okay. However, as human beings, we are having some knack by which we are ignoring the variabilities, but we are recognizing these shapes, and then we are going on to the basic geometry and recognizing the characters. More than that, our recognition is also tuned because we know the language. So we know that which character is following which, and like that. So like that we will go on. Okay. I know how I am doing with respect to the time, because if I am running short of time, please let me know. Okay. So yeah, thanks. Let me come to the part where we are talking about the computer systems. And this quickly I will say that one of the main works which is that how do I allocate resources in a computer system. Okay, so in a computer system we are having many jobs which are running. Alright, and obviously job performance depends on how I allocate resources like memory and scheduling and things like that. Okay, so what we did was that in my research work that we used the cache management. We used the machine learning approach by which we looked at the programs, the static executable program, and then we tried to analyze it, and that how it will be with respect to the cache management. Okay, so we were able to show that it is possible to predict the cache management, and different types of programs were there which needed cache. And always what happens is that when you have a job, there is something called a job mix. You will be co-running a number of programs. So which set of programs should be run together? Okay, so that is what our work was helping for that. Okay, so the regression models which were trained, they were holding up, and in the published work it was doing well. Okay, and now that is for a single processor performance. If we talk about that, these days we are having a distributed system. So now you have what is called as MapReduce. MapReduce, or some of you might be knowing that much better as Apache or Apache Spark, or it is also known as Hadoop. Okay, so these kind of things were there, and then with my student we worked on that, and there we were using this reinforcement learning, and we could find out that the task trackers and identify the task trackers which were slow, and then we try to optimize on that, and that was leading to a better performance. I think so. System security is where a lot of machine learning was there, and even now it is being used. That is, there's the sequences of programs which are being run by a system is used to identify whether the system is compromised or not. And this is we had published some work which is making use of hidden Markov model and like that. So masquerade attacks were being detected, and replica and others kind of things were there. We used rough set theory for doing the replica selection, where in a distributed system in grids, which is the most similar where we can have the replicas, and this was also solved in another it's the first time that the rough set theory was used in this kind of problem. Okay, then there is another work which is on trust models. So here, so just let me give you an idea. Trust model is like, many times you hear, say between, maybe just I'm joking that the husband and wife are there, and the wife says, no, I don't trust you. Okay, so but then how do we bring up trust? All right. So what your behavior is, or what you speak, or what you do, that gives out the trust. Similarly, we applied this concept in the wireless networks environment, and we made some trust formulations. Okay, and so like that, and then we built the trust formulations, and then we applied it into the mobile ad hoc networks. Okay, to find out whether nodes are malicious. Okay, and those nodes which are behaving in a way which is going to bring down the network. Okay, so we were able to identify that, and the routing in MANET depends very much on how the nodes are cooperating. Okay, so we were coming up with an approach to bypass that. Okay, so that's how we could do that. Some applications of neural networks are also there. Okay, and maybe we can I can close here. We can have any talk or question answers, etc. Okay, these are the references. Fine, it's all from my own published work. Okay, right. Thank you so much.
Any questions? Just ask.
Thank you, sir. Any questions? Audience, students, distinguished participants, you can ask your questions. Sir has done real research in AI and ML.
Question could be anything. It could be not necessarily even from this presentation. If you have any general question, yeah, please.
Curiosity. So you spoke about human interaction, right? and you have been working on AI. So I'm just curious because you also mentioned about speech recognition. So what is your take on AI with human disability? Because we have been trying to implicate a lot of things. Like if we talk about Stephen Hawking, he wasn't able to move at all, but then all the theories that have come up was basically the human interface with AI, right? So I'm wondering now in today's time when China is coming up with so much of robotics, is there a possibility or what is the future of AI along with the disability, the mental or emotional disability that people have?
Very rightly said. The Stephen Hawking example is the one of the best examples of how the speech recognition was used. Okay, so Stephen Hawking had huge amounts of problems, difficulties, and all that. Even at times he could not even speak. He could speak, but later on his speech even that also got into difficulty. He used to have some eye movements, and through the eye movements that was being AI systems were used to get the context and being able to work with that. So um, these are all called as assistive technologies. So assistive technologies and AI is a very huge domain of research work, and I would say that if any one of you is interested to get into something, assistive technologies for AI is definitely a good place to get into. And as Madam has mentioned, robotics. Um, Assistive technologies and robotics is one of another very good, excellent upcoming areas. In fact, just for example, suppose somebody is not able to walk, but can I have a intelligent wheelchair by which without that person having to steer it or too much, the chair itself finds out the way and takes the person along the free path. These kind of things are possible, very much possible. It just needs somebody inspired enough to sort of put everything together and work on that. Okay, so it's not just I think um, robotics is going to be really very important, not only just maybe for these kind of things, but even in our country as manufacturing or industry 4.0 is going to be there with the robots, and all the production orientation will be going along this direction of the industry 4.0. So I think it's an extremely important thing that we know a bit more about hardware, the interfacing of humans with hardware like robotics. Okay, if I may talk something more about the assistive technologies. Suppose we are having lots of people whose limbs are not working. Okay, so can we take the nerve impulses and attach an artificial limb for them, and they may be able to use it or manipulate it like a regular limb. Okay, these are some very important use cases where there is certainly some success, and still a lot further can also be done. Okay, thanks for raising that.
Thank you so much, sir. Anyone else?
So my question is, in past presentation you said about the nodes represented as atoms. What is the concept of atom there?
Okay.
And second question is, how that your research, how will we use your research or your expertise in including this technology in braille script like character recognition for blind people or visually impaired persons?
Okay. Um, the aspect about which I mentioned in dictionary learning atom is that it is a vector. It is a vector actually, but which you are not going to break it down further into components. So anything atomic means that you cannot break it down further. All right. Suppose I have a very large dimensional vector. All right, but I'm using dictionary learning method to learn the atoms. Okay, so that is, it is a shorter version of the dimension high dimension vector, which is representing some objects. Okay, and it will not be possible to reconstruct. Always we look at, if you say dimensionality reduction, it makes sense to be able to reconstruct from that. Alright, so if you break down an atom, then the reconstruction will suffer drastically. Okay, so it won't make sense to sort of take a vector and break it down still further, and the extent to which we can break down the vector and preserve the information, that would be called as an atom. Okay, so that atom is that if you are able to take the entire data matrix and reduce it into those atoms, by which you will be able to reconstruct that data to some within some error limits. Okay, so basically that is the concept. Now, as to that application of OCR for blind and braille and all that, that is already there. In fact, one of the important works which is going on with Microsoft and other such things is that, in fact, big corporations have invested heavily in the assistive technologies. From text on a page, that is an image, into the braille text, or from instead of braille only, it can even go into speech. Okay, so what you do is that from image it goes into the character set, and then from the character set into the speech. Okay, so these kind of text to speech systems are also being interfaced to OCR systems. Okay, I hope that satisfies. Yes.
Sir, in your slide you mentioned about the PCA.
Yes.
For dimensionality reduction.
Yes.
Right? And you also mentioned that you have done some sort of your work in terms of extending PCA.
Yes.
As sub-X, wherein PCA is a subset of that.
Yes.
General PCA we do is we try to reduce the number of features.
Correct.
So that we don't want it to put extra burden on the algorithms.
Yes.
So, but how your sub-X is different from that PCA?
Okay. So let me explain. PCA, as you know, that we have a that is, if you take some data, we have to compute the covariance matrix. All right. So if we have to find covariance matrix. Okay. The solution of the Cayley-Hamilton theorem to the covariance matrix is the principal components. Okay. So that is basically the definition. Now, as you know, covariance matrix is, my dimensionality is D, it will be D into D square, order of D square. Okay. And in images where the image sizes are going on increasing, alright, so then the D square will be very, very huge. Alright, so if it is 1000 by 1000, it will become 1 million size. Alright, 1 million size for any kind of matrix, even with modern kind of things, is a huge computation. Alright, in sub-X PCA what we did was that we said that we can take this and break down into components which are smaller. And then we proved through that sub-X PCA can reconstruct with this kind of breaking down into smaller chunks, and there is not such a significant loss as compared to the regular PCA. Okay, so basically we did what is called as feature partitioning. Okay, data partitioning everyone may be familiar with. I have a huge data. I will just take some chunks out of the data. I'll process one chunk, another chunk, another chunk. But you cannot do this just blindly like that for PCA. Okay, because you are dealing with features. Okay, so that's what in sub-X PCA the main thing which we did, what we showed that sub-X PCA is allowing us to break down the features into some kind of partitions, and then we have a method by which we can apply PCA once again on some data extracted from the partitions, and therefore we are able to reconstruct to a good extent the original PCA. Okay, that's sort of proved in the research papers which are published.
Can we have access to that paper?
Yeah, it's the easiest thing is like you just visit my Google Scholar profile, and then all the things will be there. In if you are having in this university IEEE Explore access and all that, you can download everything. Not just IEEE Explore, other Science Direct or other such kind of things. So you'll be able to easily download all of them. Right?
Anyone else? Thank you.
Please, sir. Stay there.
Thank you so much. Thank you so much, Sir Dr. Atul Negi, Professor and Dean, School of Computer and Information Sciences, Hyderabad Central University. Sir has explained his own research in artificial intelligence and machine learning, human-computer interaction, and OCR concepts in Telugu, Bengali, and other languages. And Sir has explained a good mechanism to how the text is becoming to the speech. Thank you so much, sir, and thank you so much for your intelligent clarification to the participants' questions in this 8th International Conference on RISE 2023. Ladies and gentlemen, now I invite Professor Pradeep Kumar, convener RISE 2023 and Head Department of Computer Science and Information Technology, to present a shawl and moment to Dr. Atul Negi sir as a token of appreciation. Give a big applause to sir.
Please a big round of applause.
Thank you, Professor Pradeep Kumar sir. Ladies and gentlemen, do you know the research in current areas, social intelligence, environment intelligence, network intelligence, artificial life, people-centered computers, man-mission team, and intelligent data analysis? I believe you are going to represent all the papers on all these areas. Ladies and gentlemen and dear students, it is time to move forward to have our technical sessions in various areas. Kindly see your schedule and occupy your chairs. Before that, I request all professors and participants to assemble on stage to take a beautiful image with our respected keynote speaker Atul Negi sir.
Thank you. Yeah, please. Here only, no?